Today we're going to talk about some desert explorers. One very famous desert explorer and scientist was Ralph Alger Bagnold. He worked in the field of aeolian, which means wind-driven physics, and he developed many of the theories that we use to understand sand motion and sand dunes today. And this just shows some figures from his famous book from back in the 1950s, showing grain paths over sand and over pebble surfaces. And he did lots of these wind tunnel measurements, but also a lot of measurements out in the desert, in the field. And during World War II, when he was a British soldier, Bagnold founded a behind-the-lines espionage, reconnaissance and raiding unit that was named the Long Range Desert Group. But before World War II, he and colleagues had already made many desert trips, making field measurements and exploring dunes. And this is a fantastic video, that was taken, or movie that was taken by that one of his group on one of those trips, and it shows how they took these Ford, I think Model A trucks, out into the desert, and they were basically driving these cars over the sand. And there's Bagnold, I think, behind the wheel. So they're out there in the desert and trying to prove, and actually proving very well, that these cars could be driven across this sand. However, the cars would occasionally get bogged down. And you can see those tire prints from, I guess, a previous car that had driven down that slope. And this one gets stuck in the sand here, so they have a very nifty technique for getting it out of the sand, which involves wooden planks carried on the top and a snow chain-like rope ladder that they then have to unravel in front of the wheels in order to present a surface that can be driven out along. And this is all happening in the 1930s. And so there they go, get it moving, get it unbogged from that sand, and then they have to run to catch up. No, I'm sure it waited for them. So it was pretty impressive that these people would go on, usually in 2 or 3 of these cars, out into the desert, and then they'd get resupplied every so often by airplanes and get boxes given to them, and there's someone cooking a meal and using the remains of some of these crates. But the really important thing, and I love this, the really important thing to have was to the distribution of the cookies. And I love that they look like they've just wandered out into their English country garden, and instead they're out there in the middle of the Sahara Desert. And there is Bagnold making measurements and setting up what looks like perhaps a Met mast or something. Perhaps making, I think they were making measurements of the height of the dunes as they went through this part of the desert, because they were mapping these dune areas that really had not been mapped. This was before you had a lot of mapping done by, aerial and satellites, of course, no satellites at this point. So, a lot of stuff was actually not that well known about this geography. Oh, yes, and there was someone with the more cookies, or biscuits, as we would say in Britain. So anyway, this was kind of the forerunner of desert explorers that we now have that we're now sending out to Mars and other planets. So while humans haven't yet reached Mars, we have sent robotic explorers, and this is the Opportunity Mars Exploration Rover. And it's one of 4 NASA rovers that have so far left sand tracks on the sands of Mars. And you see these beautiful tracks here along the dunes. But in April of 2005, which was less than a Mars year after landing, Opportunity became stuck in deep sand. And it took quite a long time to dig itself out. So you can see this is a movie showing the wheel being run backwards through the sand to try and dig itself out of that place. And each time you see the shadow move across from one side to another, that is actually a full day. You're seeing, so each one of those changes of those shadows is a new day, and then when it starts moving quickly, that's when the wheel has been unstuck. So let's count and see 1, 2, 3, 4, 5, 6, maybe days that we could see there of just that little bit of movie trying to figure out how to get unstuck. And actually, it took a full 6 weeks of careful maneuvering and trying things like this and testing things out in the test bed back at JPL in Pasadena to try and figure out how to get unstuck before that could be freed. So one might argue that it would have been a lot easier if there had been Bagnold and a few of his pals out there to stick a plank of wood and some rope under it. Anyway, this is kind of significant because if you think about this, if we hadn't been able to get Opportunity unstuck, then Opportunity would not have been able to explore Mars, including the beautiful Victoria crater, for so many more years. And because you can see 2005 was way back near the start of the mission, and the mission did not end until 2018. So the latest Mars rover to land, Curiosity, which as you can see is significantly larger than the Mir rovers, landed in Gale Crater on Mars, and it actually explored dunes that were named after Bagnold that are in Gale Crater. And this is a figure showing where we landed, and then the path of the rover sort of almost parallel to the dunes, but slowly making its way towards the dunes. And then we went in through the dunes and then began up the slopes of Mount Sharp. And here's a better look at the 2 dunes that Curiosity got closest to, High Dune and Namib Dune. We know from orbital images taken several months or years apart that these dunes are still active, so they are still moving. And in Namib Dune, we first parked in the lee of the dune, and this image was taken by HiRISE looking down at the dune while the rover was sitting there, so that is Curiosity. And here we made measurements of winds, and we imaged the dune's slit face to look for changes and to better understand how the dune formed and what type of sand it's made of. So a lot like the kind of measurements that Bagnold and other desert explorers since and before have made of dunes on Earth. And this is an image that was taken while we were sitting there, looking towards that inside slit face of the dune. And it sort of looks like it's going the other direction in the image because the camera had sort of a fisheye effect. And then we moved and we drove round up to the dune's side and actually dug into it. And again, that's something that geologists on Earth would want to do, and Aeolian scientists on Earth would want to do, to dig into the dunes, to try and look at the layering and the structuring beneath to try and get an idea of their history. And so this is a self-portrait looking south from here, and the self-portraits are taken by the camera on the arm, Marley, and they're taken from different locations, and then they're stitched together to cleverly be able to remove out the actual arm itself. So it's why it looks like it was taken by somebody, but it was in truth a self-portrait. Namib Dune has these beautiful giant ripples on its surface. Ripples of this size may be unique to Mars because of its low gravity or its thin atmosphere. And so this is another thing that's fascinating about studying Mars and comparing it to Earth. With Curiosity, we were very careful not to get stuck in the sand at the Bagnold dunes. In the future, rovers to the Moon, Mars, and maybe someday Titan will have more ways to get unstuck. And so you can see the rover at the bottom right is wiggling its way out, and the rover at the top left is sort of stepping its way out the same way that a human might.